Hey guys, welcome back to another episode of Low Spec Labs. On today's episode, we're going to be going over a very interesting topic here, right? And that topic is going to be, Proxmox LXCs, right? So, what are LXCs or Linux containers? So, what are LXCs? LXCs or Linux containers are basically LXCs are basically Linux subprocesses that are given their own storage and memory and networking, right? Their memory is basically its own encrypted storage space that's separate from the main operating system of the Linux host that it's running on, right? Inside of that container, there can either be like a limited Linux file system or there can be a whole like Linux subsystem there, right? The important thing is that they do share the same kernel. Okay, so it's very lightweight, and because it's its own like basically Linux subsystem inside of that container, you can do cool things like use it for file servers, use it for basically a lightweight method of deploying services. Right, Linux is containers are very lightweight, only a few megabytes to get them running. Right, and other than the memory they need to run your service, they don't really take up more than that, right? So you can have something like a reverse proxy running on like 512 megabytes of RAM, and that would be more than sufficient to do lots of powerful things. And I should know, right? I use Caddy server, which is like a reverse proxy slash web server, right? And I use that to host or to reverse proxy some of my own internal services out to the web. So that Caddy container is like 512 megabytes. It's been running fine for years. It is a very easy method to set up reverse proxying, right? So on today's video, I'm going to show you how to set up a Linux container in Proxmox, right? Before we get started, I should talk about some advantages. Like I said, Linux containers are very lightweight. They're very easy to set up, right? They run on the Linux host itself, so there's not really okay. So Linux containers are very lightweight, right? They use very minimum amounts of RAM. They have their own storage and their own networking, right? That actually makes them a very convenient way to set up web services. And we're gonna go through setting up a Linux container in Proxmox today, right? As we go through that, I'm going to talk about some of the advantages, you know, and some of the disadvantages, right? There's some pros and cons, right? For instance, if you wanted your web service to stay alive, like if you had a HA environment and you wanted your web service to stay alive if the Proxmox host died, like no downtime, a very minimum downtime, you probably want to set up a virtual machine, right? And maybe have that virtual machine like be able to live migrate. Linux containers don't really live migrate. The containers have to shut down, and then they send the container and basically over to another host, or they spin that container back up on that other host if it's like highly available storage, right? Or if there's some form of highly available storage available. So there's there's some pros and cons to it, right? Let's get started with this though. So as you can see right here, I do have a Linux container already running. Our proxy, that is a Caddy server, right? And I just like to use Caddy against like 512 megabytes. You can see it's using 0% of CPU. It's using 5.3% of storage, so it's using like 27 megabytes to actually run the service. It's nothing, right? And so this is really where the advantage of Linux containers come in. They're very lightweight, right? They use very minimum resources, right? Like if you had a Proxmox node with like 8 gigs of RAM and you wanted to run a couple web services, a Linux container would be my preferred method to run those services, right? So if you are in a RAM, well, I don't know. I'm not gonna bash on anybody's environment. I don't know your situation in life. I don't know in what situation you would have a hypervisor host with 8 gigs of RAM. If you are out there and this is your existence, I shall pray for you. Oh my god. But if this is just some fun lab stuff, Linux containers are going to be very powerful and very useful for you. All right? Let's continue. So, when you're creating a Linux container, right click on your Proxmox node, click create container, and we'll call this test container. Right? So there's two types of Linux containers. The first type is unprivileged containers. The second type is, well, nesting. Basically, nesting means you're going to be running something like Docker inside of this container, right? The difference between an unprivileged container and a privileged container. So unchecking this makes this container privileged, right? And basically that means this container runs as root, or it can run with like root level permissions, which defeats the entire purpose of a container. If you're running a container with root level permission, you're basically running that container as you're giving that container all access rights to the host, or various access rights to the host that you shouldn't be giving it, right? So, or that's a basic summary, and I'm kind of too dumb to. I'm half retarded, guys. You gotta give me some leeway here, right? But if you hear me spouting some bullshit, call me out. I'll do some research and I'll make a correction video. Until then, let's continue. Let's continue here. All right. So we've got our test container. We're going to make sure it's an unprivileged container, so it's actually like a lockdown memory system, or I don't know how to describe that. Maybe I shouldn't be discussing it then. So if you can't describe it, you don't know it too well. Let's go. All right. So you create a password for containers like root account, right? Here you can load an SSH public key. I don't have any public key I'd like to load into here, right? But if you did have a public key, what you could do is load your pub key file in here, right? And then when the container is spun up, you could just SSH into that container using your pub key from your local machine, which is very convenient depending on what you're setting it up for. If you have Ansible running, you could set these containers up in such a way that you put the Ansible host's pub key file here. The Ansible host reaches out and then auto configures these containers after they're spun up. Right? There's lots of cool things you can do with this. Templates, local. Okay. So what we have to do is download templates. Right? So on this host, I think I already have the templates downloaded. Let's go here. Let's go to local. You can see I already have a Debian template downloaded. If you don't have a template downloaded, what you do is you click your Proxmox node, go down to local, click templates, and I'm a Debian fan. Debian, let's see, 10 standard, download. Let's give it a couple seconds here. And there we go, boys. Right. So now let's go back, create container, and unprivileged container. Next, and look at that, Debian 10 storage. We'll give this 8 gigs of RAM, or 8 gigs of, so this is not RAM storage, this is actually disk, right? So when you do this, you'll get a storage option. I only have local ZFS storage at this time, so that's fine. CPU, cores is 1, memory. Let's give this 1 gig. Let's be a little. I got memory for days, Right, big memory energy here, guys. Right, virtual bridge. I believe it's virtual bridge 0. IP address is DHCP. Right. VLAN tag, there's no VLAN tag on this, or I can add it later. DNS, use host settings, so I don't remember what my DNS settings are, right? But let me explain this real quick before we proceed. So DNS domain, so if you had a DNS server or a local DNS server, you'd set your local.domain here. So if I had a local domain called test.local would go here, and then I'd point it to the DNS server's IP address. So if that IP was like my domain controller, that'd be like, 192.168.0.10 or something like that, right? Click confirm and click finish. So I have the test container here. Let's see. No, console. All right. So let's log in. Now let's see if we can figure out what the IP address of this is. It has to have one. Containers don't come up unless they have an IP address. So IP is 192.168.0.102. Right? Okay, that's cool. So let's see. Update. What I like to do is go in. It must be accepted before sweep value from stable updates to old stable updates. Damn, something's changed. Hold on. I'll be back and do some research. Okay, we are back. Right. So here's what we're gonna do. We're at the root file system. No need for sudo. Right. So the command you want to type in is apt. Well, the command you want to type in is apt get allow release change info update. Apt get update.y. Apt get upgrade. Yep. Right. And the cool thing about containers is you can turn them into templates. Right. And it's a quick way to spin up basically like a jail file system to get services running. And they spin up way quicker than like virtual machines. Like containers spin up like that. They're very intuitive, especially once you get to know them. So you can see this is basically running or upgrading as if it's its own independent, Linux virtual machine, right? It's not. It's actually a process on this host. Like for instance, if I wanted to show. All right. So as you can see, this is basically like a virtual machine from the Proxmox web interface, right? But the cool thing about containers is even though they have their own separate networking, it's got its own IP address, right? It's got it's got its own DNS server. It's got like some quick options here. It's got its own storage, right? It's got its own memory, right? It's even got its own like CPU resource allocation, but it's actually just a process running on the Linux kernel, right? Or running on the Linux host. For instance, we typed in htop, right? And we searched in htop for the container's ID. Oops, let's try that again. Right. You can see right here, it's just a process, right? Running. There you go. Right here. So you can see it's just a process running on the Linux host itself. And the cool thing is it's one we can actually access natively through the Proxmox web UI. Right. So let's see. Let's see if that upgrade is done. Yeah, it is. Okay. So now that upgrade is done, all right. So okay. And now it's installing htop, glances, Ranger, right? So htop is like a process utility that you use to manage, web processes. Glances is like it's like a fancier. Well, I'll show you. In a second here. All right. Okay. All right. So the cool thing about containers is not only are they very lightweight, but you can kind of use them as templates as well. If you need to spin up a bunch of services and you have the pub key there, you can kind of use containers as a quick way to, get some pretty complex infrastructure spun up pretty efficiently, right? You could include the pub key inside of the Linux host. You could include your web services, right? You could have an Ansible host reach out and configure, like your file server, your web servers. It's pretty cool, right? And I've played around with it a little bit, and I'm hoping I can make some videos on that when I get some time, right? Let's see here. Okay, so let's continue. So there's a couple services I like to install in my containers. The first one being HTOP, which is just like a fancier version of Top, which is like a process managing utility, right? So inside of the container itself, it has like its own sub processes, and maybe you want to kill your web servers without like forcibly restarting a container. It's convenient for that. It's just a more friendly way to manage Top, right? I like to use Glances, right, which is like a fancy basically like task manager type utility, right? You can still use Top to like stop a process, but Glances give you a quick glance around, you know, stuff inside of a container, like what process is using memory. So if you notice the containers, slowly using more and more memory, you can kind of go inside of here and figure out what exactly is going on. And I like to use Ranger. And Ranger is basically like just this nice text-based file browsing utility, right? Just to make things a little bit easier. They're simple management tools, but they make um, just life a little bit easier when you do have to manage these. So, okay. So now you start it back up. Test container. All right. So at this point, as far as I'm considered, this is ready to be converted to a template. All right. Let's give this a few seconds here. All right. Refresh the Proxmox host. Nope. Still converting. It says tasks. Okay. There we go. Right. The cool thing about container templates is you can clone them out. Either as a link clone, as a full clone as well. Right. I feel like containers are so lightweight you can go and convert them into full clones, and then just call this CD2. Right. You clone it out. But you can also clone that as a link clone. Call this test CT3. You clone it out. So we're gonna have to wait a little bit here. Let's see. Let's give it a couple seconds here. We'll check that a bit. Okay. Alright. So basically what just happened there was I tried to create two templates at once, right, off of this. And because this template was being created, it locked the disk, right? And so now it's kind of like stuck right here. Like it locked the root disk of this container here, right? Because it's got to copy it, right? And because it locked the root disk of this container, it kind of messed up, let's see, the cloning status of this container. So we'll give this a couple minutes. I mean, it looks like it's coming up. It says create summary. Looks like it's got the right stuff. Bootable disk size is half what it should be though. We'll come back and we'll wait and we'll see. Right. So we're gonna start this one up though. Right. You can see that one spun up very quickly. The spin up time on containers is like a couple seconds, which is very convenient, especially if you need to get like some early stage processes spun up, right? You can schedule things, like you can go into here, into options, right? Shut down order, right? You can schedule this to be the first thing to start up on this host, right? And let's see, options here. Startup delay, start on boot delay, default. Right. So you can set this to be like the first thing startup. So let's say you needed like a directory server, right? If you had like a Linux-based directory server, you could get that spun up in a few seconds on your container. Well, get the container itself started. The directory server is probably going to take another couple seconds to get running, right? But it'd be a nice and a quick way to get, like a file server up and running, a web server up and running, just depending on what you want to use it for.